Good evening to everyone. This is Dr. Polaiah, Professor in the Department of CSE Data Science. I am here to deliver today's video lecture on basic concepts in sampling and quantization of digital image processing. As we are aware, in our videos lecture, as we are going to be to keep our agenda for completion of this topic. The topic which today we are going to be start from these 4 points of the agenda only. Number 1 is a topic introduction. Number 2, how this topic can be mapped with the help of COs and POs, which are already defined in our standard departments points. So coming to the third point, that is basic concepts in sampling and quantization process. So next, once we understood this concept, how can we use in the applications, especially in the digital image processing applications. Once we understood this digital image processing application based, this topic is nothing but we are in the achievement of your learned concept. So that learned concept, how can be mapped with the learned outcomes? In this sense, you maybe know that the topic which today we are going to discuss is some basic. What is that? Some basics of, actually here it is by mistake scheme. Actually this is not this. So what is here? Our basic in sampling and quantization. Of digital image processing. So this is our topic. Today's topic is this one, not this one. I'm sorry for that. So coming to this topic which we are going to be learn, what this topic, how we are going to be achieve in terms of your learning outcome. In terms of your learning outcome means you are going to gain the knowledge regarding the concept of simple basics in sampling and quantization of a digital image processing. So in the digital image processing, obviously 100% we are going to use these concepts. Okay. Next, this concept, once you are got the knowledge, immediately we are going to be check that knowledge how we can use in terms of digital image system. How can we use that knowledge towards to develop digital imaging system? So this digital imaging system is right now we are going to be developed with the help of this concept, today concept, this complete knowledge. Okay. So this concept means here what you want to understand, the topic which you are going to learn. So the topic is here sampling and quantization topic. Okay. So what is the meaning of sampling and quantization? So that is what we want to understand here. The meaning of excuse me, the quantization, the meaning of quantizations means the number of quantization levels should be high enough for human perception of fine shading details in the image. Okay. If you take an image, okay, in this image you are going to be see the perception of fine shading details in particular image. Okay, in particular image. So this one occurs of false contours is the main problem in image which has been quantized with insufficient brightness levels. Okay, so we are going to be see the brightness levels of your particular image. How can you find that the brightness of the image? In the sense you are going to be keep this image in terms of achievement of digital image, in terms of achievement of digital image. For the achievement of that digital image, which we want to concentrate here here, mostly here, there are two types of methods used for the image processing, namely, number one, analog image processing. Sorry. Analog image processing is one. Second one is digital image processing. Okay. So here, basically, we are studying is simply image processing and analysis subject. Okay. So we had to concentrate both analog image processing as well as digital image processing. Both we have to do concentrate. If we are going to concentrate both of topic, then how your concepts in digital image processing can be happened. In the sense, analog image processing can be used hard copies like printouts and photographs. Whereas this image analysis use various fundamentals of interpretation while using the usual techniques. Okay, so these usual techniques, of course, we have in detail discussion later on. So we can discuss later, no need to worry. But coming to the compare with this analog image processing with digital image processing technique, it helps the manipulation of digital images by using the computer's technology. So this computer technology is going to be help us mostly how can we convert an analog image into digital. Okay, so the three general phases that all types of data have to undergo while using digital technique for the pre-processing, enhancement and display and also we can information extraction. So that means digital image processing means whenever you convert an analog image into digital, so that image we can go and use for the digital techniques in terms of pre-processing, in terms of enhancement. What do you mean enhancement? Image enhancement. And that image need to be displayed in terms of very clearly, 100% accuracy, displacement, display. You wanted to see that 100%, we can display that whenever it is converted into digital. And also, if you want to extract any information from the image, we can also extract. Okay. So how can we do that? How can we achieve that? In order to become suitable for digital processing, an image function that is we called as f of x comma y must be digitized both spatially and in amplitude value. So typically, frame grabber or digitizer is used to sample and quantize the analog video signal. Okay. Hence, in order to create an image which is 100% digital, we need to convert analog, that is continuous data, into digital form. Okay. So that means, and a continuous data means here, what do you mean to understand here? This is nothing but a continuous signal. This is like a continuous signal. See, the duration of the time is in continuous. The duration of the signal is continuous. It has certain amplitude, peak to peak amplitude, and the value of the time factor will be changes at x-axis and y-axis. So based on this y-axis and x-axis, the image, if you are going to be defined as a image function x comma y. So this f of x comma y easily run with the help of your digitized analog values of amplitude of the signal and the time factor. Okay. So when we going to be see this analog signal into digital, so what we want to do is there are two steps in which it is done for conversion into digital. So this analog will be converted into digital. There are the two steps only. Step number one, sampling. Step number two, quantization. Step number one is sampling and step number two is quantization. So now, what does it mean? Sampling. Sampling rates determines the spatial resolutions of digitized image, while the quantized levels determines the number of gray levels in the digitized image. That means a magnitude of the sampled image is expressed as a digital value in digital image processing. So what you want to understand from here is the transition between analog means continuous values of the image function and its digital equivalent is called quantization. Now you can understand sampling. Sampling rate determines the spatial resolution. But whereas quantization defines simply transition between continuous values of the image function and its digital equivalent is called quantization. So we'll see this complete process which we wanted to understand. Okay, the sampling is the process of converting a signal that is a function of continuous time or space into a numeric sequence. That means the process is also called analog to digital conversion or simply digitizing. So also it needs amplitude y-axis so that the part that deals with the digitization of coordinates is known as sampling. So what do you want to understand from here is in digitizing sampling is done on independent variable process. In case of that independent variable process in that, let you see the equation y equal to sine of x where x is the variable. What is the x here? Here x can be independently changed, but y will be dependent. Okay. So now what do you want to understand from here is quantization is the opposite to sampling because it is done on y-axis while sampling is done on x-axis. I'll repeat once again. Quantization is the opposite to the sampling because it is done on y-axis while sampling is done on x-axis. Quite opposite, x and y. So quantization is a process of transforming a real valued sampled image to one taking only a finite number of distinct values. Under quantization process, the amplitude values of the images are digitized. You see, quantization process, the amplitude values of the images are digitized. So quantization process is we can simply in terms of amplitude values of the image are digitized. Okay. Now amplitude is digitized. So that means simple words, when you are quantizing an image, you are actually dividing a signal into quanta, nothing but partitions. A signal, that is, what is a signal is here. This is a signal. Okay. This signal is right now quantization, means partitions. How we are going to partition? In equal intervals. We are going to be define that equal intervals of n value. According to this n value and multiplication of each instant value, we are going to be see that. Okay. So we'll see in detail in coming slide. So what do you want to understand from this here? Let you see that the basic introduction about this topic, which is we are completely concentrating on a digital signal is superior to an analog signal because it is more robust to noise and can easily be recovered, corrected and amplified. So that is the importance of digital signal. So for this reason, the tendency today is to change an analog signal into digital data. So that means being it is a signal, okay, so signal will be analog. This is called a signal, maybe analog. This signal right now keeping into the data. That data also digital data. So a signal, that means an analog signal is converted into digitized. Digitized means digitized data. Okay. So now, excuse me. What do we want to understand from here? So that means the importance which we want to concentrate here is an analog image is converted into digital image is nothing but analog image which we are going to be considered as a signal in terms of in terms of analog image data signal. So that data we are going to be considered here, an analog signal is in terms of amplitude can take any value over a continuous range. The range you may be defined from 0 to 10. What do you mean 10 seconds? So what is this range? This range means depends upon this range, your signal will be continuously changes. So this is the range of t value, and fixing the amplitude value. Amplitude value will be fixed. That is peak to peak amplitude value. We are going to be fixed. So depends upon that range, it continuous changes. And that signal right now you are going to be keeping into the digital signal. What do you mean digital signal? Amplitude can take only in terms of discrete, not continuous, and finite values. The values are finite, so it is not keep on changes. So that means your analog signal will be there, but here the values which we are going to be instantly changes. That means your signal is there, continuously changes. So like this, you see, these are the instants. These are the instants. Okay, so this is actually continuous signal, but this discrete points are considered as a digital signal data. Okay. Now you see here, changing analog signal to digital signal is first we have to do sampling. Next we have to do the quantization and going to get your coding based signal. Okay. So what do you mean that? What is analog signal is here? Analog signal is here is this one. So here time factor t. Here the amplitude value is here maybe represent, being it is a electrical signal as an analog signal, amplitude obviously voltage only, and that voltage will be vary either in terms of frequency or time factor. We keeping here time factor. Now you are going to be change this analog signal into digital. How it may be happen? How it may be happen in the sense, this analog signal is converted into digital. First you have to do the samples. First you have to fix the sampling instance. What we call as sampling instance. Depends upon the signal, we are going to fix the sampling instance. These are all the sampling instance, sampling time. And this y-axis we are going to vary, that is amplitude value will be vary until up to you can define this amplitude value according to your signal. Now after this sampling, that is quantization, that is instance divided, then we are going to be keeping into the quantization. What do you mean quantization? Now this analog part is right now depends upon sampling periods, sampling instance values. Now we keeping into the only that instant sampling is nothing but quantization. These are all the values. Okay, so your quantized values are here. Your amplitude values will be changes in terms of what we call is, you are defining in terms of digital. So digital means your amplitude value may be changes in terms of maximum 3 bits, means 2 power of 3. That is equal to 8 combinations. So you see 1, 2, 3, 4, 5, 6, 7, 8. So 0 to 7 will be very. So 3-bit signal you are getting here, digitized signal is 3-bit signal. Being you are called as a signal in terms of digital data means the data which is here 3-bit data. The data which we are in here is obviously one instant to the another only based on this data only. This data. You want to understand that that instead of amplitude values, how it can be vary, you can see here. You can vary here according to your amplitude values. Your instantly changes. Sorry. So instantly changes is nothing but your coding. So first one is sampling is this, second one is quantization is this, and coding. Coding means instantly changes of your clock pulses. So that is what we wanted to understand from here. This coding is nothing but your complete signal is here in terms of binary data signal. Binary data signal. That is called a coding signal. Okay. Next, coming to the point, what we want to understand from here, once you gone through the sampling, connecting with the quantization and connected to your original binary data signal, nothing but coding signal. Okay. That means one can convert an analog signal to digital signal by using sampling and quantization only. So that means when we convert analog signal to digital, then what we call as, we call that one simply analog to digital conversion only. Obviously, that analog to digital conversion is completely depends on the concept of sampling as well as quantization. Sampling as well as quantization. So the processed signals are then converted back to analog signals using reconstruction or interruption operation. That means you wanted to convert your digital to analog, you can convert. So that our topic is here completely concentrate on analog to digital only. That is what we want to concentrate here, sampling and quantization. Now, sampling process is a basic operation in the digital communication. Okay, so in this process, continuous time analog signal is sampled by measuring its amplitude at a discrete instance. I said previously slide also. So sampling process is nothing but discrete instance of a particular signal which is measured in terms of amplitude. So that the continuous time analog signal is converted into corresponding sequence of samples that are usually spaced uniformly in time. It is necessary to choose the sampling rate properly. So the sequence of samples uniquely defines the original analog signal. So that is the complete understanding of the sampling process. When this sampling process, which we want to understand mathematically, so that means you take the signal is a continuous time signal is a x of t. So x of t is your continuous signal where t is the independent variable value. Is represent simply in terms of x of t. So x of t is at discrete number of points, depends on the t value only. So that is t equal to n into ts. What is this ts? This is the your sampling period. Okay. So this sampling period will be vary with the help of intervals of small n. That is number of sample periods will be vary. So how it may be vary? Let you see. You take one sample signal. This figure shows the sampling of the analog to digital. So here digital is discrete instant. Okay. So what do you mean to understand here? A signal which is like this. Okay. Here you are keeping the intervals n, ts. That number of time period. That is sampling periods. Okay. This sampling period right now you are going to be maintain equal intervals. Up to what? Your t value depends upon your defined values. It will be sampled. Okay. So simply we can say it is x of t is here nothing but s of t. That is s of t is equal to x of t. And where t is, we simply define n into ts. Number of samples. Right? So coming to this completely process which is right now we discussed in terms of mathematical processes 100% depends upon sampling theorem only. So what do you mean sampling theorem? States that a band limited signal x of t with a bandwidth w. What do you mean w is here? Highest frequency value can be reconstructed from its sample values if the sampling rate means frequency fs equal to 1 by ts. That is here. Fs equal to, what is fs? Fs is the sampling rate, that is frequency value, is greater than or equal to the twice bandwidth of the your frequency, bandwidth, band limited signal. So what is the W here? W is the highest frequency band value. This highest frequency value that can be reconstructed from its sample values with the sample rate. So that is what we want to understand. So Fs is obviously should be greater than, what is that it say? Greater than or equal to twice of the your W. What is this W? Your W is the your band limited signal of the highest frequency. So that is the frequency. When this condition is satisfied, then you are going to be proceed to do the sampling 100% towards to convert analog to digital. So the minimum sampling rate of TS is right now depends upon Fs only. Previous slide we discussed about TS. TS is depends upon here Fs. So for an analog band limited signal is called Nyquist rate. So Nyquist rate is the rate which helps us to define sample rate. That is NTS. Okay. So depends upon those values we can define our sampling process, which we can recall once again. Sampling means as long as sampling of the analog signal is taken with a sufficient high frequency, it can be shown that there is no loss in information as a result of taking discrete samples as a rate of discrete. So sampling means taking in terms of no loss information as a result of taking discrete samples. So as it is, you are converting analog to digital means 100% will convert perfectly without any loss of the analog signal or as well as digital signal. Now coming to the important part of our conversion of analog to digital is second part is quantization. In order to process the sample signal digitally, the sample values have to be quantized to finite number of levels, and each value can be represented a string of bits. So to quantize a sample value is to round it to the nearest point among a finite set of presumable values. Therefore, a distortion will inevitably occur. This is called quantization error. When our distortion will be occur, then that will be called as quantization error only. So this process is here in combining the process of sampling and quantization. The specification of the continuous time analog signal becomes limited to discrete set of values. That means it representing each of these discrete set of values as a code. Meaning of that, encoding the process. So code consists of a number of code elements called symbols. In binary code, a symbol takes one of the two distinct values. In ternary coding, the symbol may be one of the distinct values and so on for the other codes. So what do you want to understand from here? Let me take one simple example. So each zone is assigned a binary code, okay, that is here. And binary code consists of bits. How much? You see here, number of bits required to encode the zones or the number of bits per sample. is obtained as follows. This is your formula. What is the NB? NB is here, given our example, NB is equal to number of bits is 3. So 3 means 2 power of 3. 3 are the bits and the combination of your number of bits will be occurred 8. That is 8 zone level codes. Therefore, the amplitude values of the signal will be changes depends upon 3 bits, 3 bits code only. So 3 bits means you are going to be changes here. The combination of 3, how many it will become? 8. That is from 0 to 7. This is decimal. This is decimal value, but this is binary value. Okay. So here you are converting decimal to binary means the combinations are very 0, 1, 2, 3, 4, 5, 6 and 7 values. 0 to 7 means 8 values. Okay. So assigning codes to zone is here. 0 will refer to zone minus 20 to 15 volts of your amplitude. Whereas 1 means zone which we are allocated in terms of code minus 15 to minus 10. It is another amplitude of the value. Okay. So what I mean to understand from here, you see here we can understand from one signal to another signal. You consider this signal. Okay. You consider this signal. So this figure is considered the analog signal obviously. You are converted into digital by using quantization. Okay. So how it is quantization is in terms of number of samples, TS, depends upon sampling theorem. We define here the signal is first sampled. Then that value we are going to be define your x of t. Here t is replaced with x of n ts because it's sampled. Then we are going to be see that sampled signal is right now converted into your required values. See here that samples are even in terms of binary digits. See 2, 4, 6, 8, 10. What do you mean this? These are the values of analog is converted into digital. So what do you mean to understand? Your 0, 1, 2, 3. There are 2 power of 3 is equal to your 8 bits combination. So in between this, your 0 to that means quantized, that means assigned quantized values 0 to 3 to the midpoint of your zone. So your signal will be converted according to it. Okay. So now once you understood that in terms of binary, okay, in terms of binary, depends upon your zone defined. Depends upon your zone defined. Your zone maybe your zone of the amplitude signal is you are going to be defined according to this. Your number of options, that means number of possibilities are come 0 to 3. So that means here simply come 2 power of 2 equal to 4 combinations will happen. So that is here each zone is assigned a binary code value and instantly it will be very n. So this is your binary code depends upon n equal to 2. Here n equal to 2, 2 power of 2 equal to 4 combinations. So sampling quantization is here 100% help us towards to concentrate in terms of your sequence of bits if the samples are here like this. Okay. So you are going to be keep your sequence of information according to their sequence of information. Your sample data will be changes. Okay. This n. Okay. So this n value, suppose it is a 1. It is 2. Maximum it is 2 only. That is in terms of binary 3. 1 1 means 3 value in terms of 1. So it is 1. It is 3. So maximum value will be vary. It is 1. It is 0. Here 0 instant. It is 0 instant. So now we understood that the relationship of sampling and quantization is here, which is depends upon intervals as well as in terms of your quantizations of the amplitude values dependent. Okay, that varies simply 100% in terms of sequence bits. Okay, so that's what we are says that while you are converting analog to digital by using sampling and quantization process, okay, such a method helps us 100%. That means without any missing data, we'll get the digital data. You see here how it may be For example, your the image is here, f of x comma y, f of x, this is image. This is image. Okay. So that may be first what you have to do, you want to convert into digital, first do the sampling. Then f of x comma y, it become sampled frequency. Then after that you have to do the quantization. Then it become, now it is changes u of m comma n, intervals. M comma n is intervals. N is nothing but x-axis, number of sample intervals. M is nothing but y, amplitude intervals. That is digitized. So that data is now input is here to the computer. Computer is nothing but your discrete process unit. Okay. So that means your m comma n values are here discrete. That means digital. That means is simply called as binary. So your binary data will take your computer and it will run and it will provide the output of the your required digitized digital information. Okay. So that means this digital, obviously if you wanted to see, it is not possible. So in terms of real world means again you wanted to convert in this. So ADC can be worked with DAC. So both will work together and we are going to see that. How it may be happen, you see DAC how it may be happen. The computer output signal is connected to your conversion, that is digital to analog converter. And it's going to be display your targeted. This one is your target value. Here is output. Here is target. Output of the computer which is using sampling and quantization process will get your output. But that output which is in terms of discrete process, okay, in terms of digital, which cannot be used in the real world application. So that we have to use that again in terms of analog. How means you have to convert digital to analog. As per our curriculum, that is syllabus topic is here, only we are considering analog to digital, but digital to analog also very important. That's what I kept here. Quantization may going to be happen. Image sampling and quantization is in analog image will be displayed here. This is analog image will be displayed. So that is the meaning. I want to show you some examples also here. Okay, sampling in the two-dimensional space basics on image sampling. You see here, which one is more clarity, which image is better visible. So that we are going to be see here. See, by taking image for better visibility, you wanted to see that finding of the values in between this part. Okay, so this part alone, you want to see these pixels alone, you wanted to convert it to sample and quantization, so that we'll get your required values by using your gradient display method. This is gradient display method. Okay, so this gradient display method, obviously n value, that means nts, this n value will be defined in terms of Nyquist rate. So that means that intervals, number of intervals is defined in terms of fold over frequency values. So here this aliasing is obviously depends upon the Nyquist rate only. Nyquist rate, that is sampling rate. So the aliasing is depends upon Nyquist rate, and Nyquist rate will be defined depends upon your sampling rate values. So for that we are going to take the knowledge of sampling theorem. So that sampling theorem which we are going to be considered in terms of two-dimensional case only. So you can also process it in three-dimensional. But basic idea is here for easy to understand is your two-dimensional process. So the two-dimensional process in the sense, you are going to be see this interpolation of the filtering also we are going to be used in sampling and quantization. So because the distortion of the image or distortion of the signal which is in the analog form may going to have more noise. So while you are converting analog to digital, you have to concentrate about your noise also, so that whenever it is noise, then you may be sample that and reconstruct in your required manner. So for example, you see here a continuous form of the signal image is here, which is a sensor array image. Okay, that resultant image which we are going to be see here in terms of sampling and quantity. Here we cannot be find out your required image data, required image data. But whereas in case of this, we may be find when we can find because it is sampled, because it is sampled, and quantized and quantized. Okay, so it depends upon the sample and quantization only. You are going to be able to find out the pixels values. Okay, neighborhood pixel relation we can find. So we can also see that analog image in terms of analog form and convert into digital, that is quantized and a sampled process. So we will get 100% your digitized. So with this, the first book only we referred, okay, for the complete discussion of today's topic. What is our today topic is? It is simple basic concepts, okay, in terms of understanding how an analog signal is converted into digital. So by using sample and quantization method. So I'm very thankful for your concentrated listening from starting to end. Now, what I want to encourage you all of you, you please go through this video. If at all you have any doubts, we can discuss also. Okay. Thank you so much for providing this opportunity. Thank you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.